So I had planned today to go rollerblading because that's something I occasionally do. But my car had other plans because apparently keeping air in the suspension is not something that it wants to do. So my mechanic is definitely going to enjoy seeing me again. Anyway, in our last video, we installed the Kubernetes cluster in its kind of basic form. We left it as more of a shell than a running cluster. And today we're gonna lay down the foundation for all of our applications to use within this cluster. So I've basically split the software, right? We're kind of looking at the atHomeHub project here. And under the software group, we'll have these three repositories here. Applications and media are actual applications or things that we actually install. What we want to see or what we want to do today is install the foundation, right, or lay the foundation within the cluster. This is going to be the start to everything, right? Like everything that we'll be installing depends on the things that we install as part of the foundation stack, which is why I called it foundation. I hope that makes sense. And I split this into multiple stacks. So I have like the network stack, the storage stack, the observability stack, the managed services stack, the user management stack, and the tooling stack. So we'll be kind of installing all of these to get the cluster up and running. But before we go ahead and do this, we do need to have some tools installed. We primarily need three things: kubectl, and this is the CLI that we can actually use to interact with the cluster. We're not necessarily going to use the CLI, but we kind of need it. We need Helm. So let me install Helm because apparently I don't have it installed here. This is a fresh kind of operating system that I installed primarily for this. So now we have Helm. I put here K9S, and this is kind of a text or a TUI of sorts. So if we open this up, it's this CLI tool over here. And this allows us to visualize things within the cluster a bit, let's say, easier. But this might be a bit difficult to do, especially if you're at the beginning. Right, if you don't really have a lot of experience with Kubernetes and you don't know what you're looking for, K9S might be a bit difficult to get your bearings with. So I put FreeLens as an alternative, and this is does for all intents and purposes the same thing as K9S. It just has a different interface, right? It's more of a GUI based, and we can see the atHomeHub cluster shows here, so I can just add it to the hotbar, so it's available here. And if I click on it, it loads me into the cluster. So I can see the nodes here as well, and things like that. I'm also not using Cosmic Alpha on this just because I had some weird issues recording my secondary display. I don't know what's going on there. The cursor was inversed or whatever. So I switched to GNOME, and this doesn't have the same tiling options that we had with Cosmic. So that's gonna make things a bit difficult. And let me show you my setup as well before we continue, just so you kind of get a sense of what I'm sharing here. I'll be kind of bringing like a secondary display into the view. So I have my main monitor over here where I have the main screen that we're talking about, and I also have this vertical, I guess this vertical screen here. And I use this primarily to monitor things, so I don't I don't actively use it to work on it or whatever, but I usually just keep things here, and I can at a glance see what's happening within the cluster or things like that. I'll try to use the FreeLens for this video, just because it's going to kind of give you an idea of how to use it and how to work with it. I would recommend K9s for monitoring stuff, just because you can open multiple windows of K9s and each one can look at the pods or look at the ingresses or look at the certificates or whatever. Basically, whatever it is that you need to look at, you can have multiple windows with it open. But because my tiling manager is broken, I don't want to open multiple windows because it's gonna be a pain. I will maybe keep this one with the nodes here, just to kind of get a sense, at least initially, what our nodes are doing. So I'm gonna leave it like that, and we can kind of keep an eye out on it. And I think that's it. You will also need Git, but that usually comes pre-installed in most of the operating systems. So in this foundation repository, we can just clone it. So we can do this clone with HTTPS. And what I usually do is I create a dev directory in my user home. This is also a bit different than the host install. With the hosts, we don't really touch it that much post the initial install, but this will need to come back to it and update things and kind of interact with the cluster some more. So I'm just going to clone it in this directory over here, just to be able to come back to it, and then I can do like a git pull, so I can pull changes in case the repository gets updated, and then I can see what files got updated in the git pull command, so I know kind of what I need to update and whatever. But let's just open this up. I'm going to use Codium. I'm not going to use Z, just because Codium has a much better markdown support, so I can see this nicely here. And just because I've cloned it, I'm gonna close that off and move this to the left. And I'm gonna open the atHomeHub directory that we created the other time as well. I'm gonna use Codium for this as well, because why not? And if we remember, this is where we define the controllers and the README with the details of the host and whatever. So to start this off, I'm gonna create the configs, and I'm gonna create the general config. It's basically this one over here. So I'm gonna remove the comments though. This basically like the generic configuration that's going to be used across all the applications and across all the components that we'll be installing today, like all of these stacks. I call this general because we'll be referencing it as well across the other applications. So when we'll, like in the next video, we'll probably start installing applications. We'll also need this file alongside an application configuration file. And this is how it looks like in its most basic form. We'll add to this as we'll be installing things, and those will need some configuration as well. But we need to set the time zone. So this is the same as the time zone we used in the host. So if we remember here, we set the time zone to America Toronto, did the same here. We have the DNS root domain. So this will impact all of the endpoints for your applications. So for example, let's say we want to access image. Image is going to be image.app.thisroot-domain. So in your browser, you're going to have to type that to get to it. So you can customize this to your liking. I'm just going to keep it to @home. And then we need some IP addresses, similarly to how we reserved 2 IPs for the host in our DHCP controller, right, in our router. We need a range of IPs that's outside of the DHCP range that we can just use, right? So I'm gonna give it 5 IPs. We'll need a minimum of 2 to get things working. And for the hosts we use 69.5 and 69.6. So I'm leaving myself a bit of space for more hosts. If I want to add them, I'm gonna add them on 0.7, 0.8, 0.9. And from 0.10 to 0.15, I'm just leaving that as space for the applications within the cluster. Now, I want to persist this, so we're going to use this HomeHub gconfig as an environment variable. So we have a few ways to do this. So we can do export for this, and then we can put this to atHomeHub configs and general. So now if I want to just open this up, right, or reference, this is going to point to the right file. But I want to persist this, so I'm going to edit it in my zshrc file. I use zsh as my shell. This could be bashrc or fishrc or whatever. I don't know any other shell. I've been using zsh for quite a while, so I'm just kind of comfortable with it. So I can open it here, and I can just make a section at HomeHub, and I'm gonna put this export here as well. So now with this saved, every time I'm gonna open a terminal, it's gonna be set right to this file, so I don't always have to set this. And it just kind of makes it easier over time. So I'm gonna take this away. I don't need it on my main display anymore. I'll bring it back whenever we need to configure stuff. So let's just get started with the stacks. And the first one is the network stack, and these are outlined over here as well. Like if we look at the files, and I think I can I make this a bit bigger? I guess no. Okay. So I can click on the network stack, and it's gonna take me to the documentation for it. This is also here, so this is the documentation that I'm referring to in here in the networking subdirectory. Networking is, I think, one of the more, I wouldn't necessarily call complicated, but one of the bigger stacks that we have to deal with, just because it's kind of a it's kind of a fundamental thing to the cluster, let's say. And there are multiple things involved in networking, right? We do have at its core Cilium that provides our kind of overlay network within the cluster. So we can think of this as as like the equivalent of the Docker network, right? That internal network that happens between the containers. And that's what's called like an overlay network, and it will run across all of the nodes in our clusters, in our cluster, I guess. But that's just the start of it. We need a way to expose our services. So basically Cilium, we can think of it as creating another network similar to the network in our home, but these are kind of isolated, right? Like our home network and our Cilium network are two isolated things. There's no communication between them. So for that, we'll use MetalLB, and this is going to create our load balancer services. We have like 3 types of services in Kubernetes. We have the 2 main ones are cluster IP, which is only on this overlay network of Cilium, right? And it's used for service-to-service communication within the cluster. The load balancer that actually exposes things outside, right? It creates a load balancer, and this is layer 4 of the OSI stack, right? It's TCP traffic. And that's going to be managed by MetalLB. And the third type is node ports, but I haven't really found a use case for node ports, so we're going to try and stay away from those. But MetalLB is going to expose two main services for us, which is going to be the DNS server. We're going to basically install our own DNS server, and that's going to be served by Pi-hole. And the Kong, which is similar to Nginx. This is like a proxy. And this is how we're going to access all of our applications, right? We're not going to access applications by IP or anything like that, right? That's pretty savage. But we are going to proxy all of our requests through this. And the advantage of that is that proxies work at layer 7 of the OSI stack. That's the application layer. And that's where we have like HTTP traffic, and HTTP traffic is very common for all of our applications. There are like WebSockets and gRPC and whatever, but HTTP is our focus. And we'll also use Certificate Manager to add encryption to all of these. So we want our traffic to be encrypted, and that's where Cert Manager is going to come into the picture and kind of encrypt that traffic for us. Now, we did say that we're going to access these by name. So I'm not going to access an IP address or a port or anything like that, right? That's, again, pretty barbaric. So we do need a way to tell Pi-hole what services exist in the cluster and the names in which those are accessible by, I guess. And for that, we'll use external DNS. And external DNS is basically going to keep everything in sync with Pi-hole and allow our services to be kind of accessed. So if we look at all of our pods here in the cluster, we can see that we just have the two basic ones which are pending because there's no network, right? The cluster is in not ready status. So let's just start installing stuff, I guess, and networking is the first thing, as I said. And this is split into 3 substacks, I guess, or 3 components. We have core, routing, and DNS. Some of these need to be installed twice. I'm thinking we'll go into more details into why this needs to be done at a later point in time. This is just for the first install. So after we did this, we can just upgrade them with a single command. So the core networking stack is the first component that we will actually be installing. As this mentions, right, core is like fundamental to that particular stack. I know the stacks here are going to be a bit confusing because this is like the networking stack, and then within that you have the core networking stack, and I need to figure out a better way to name these. But if we want to install it, we can just go into its directory. So networking core, right, this is where it is. We can run a Helm dependency update command. This is basically going to pull in all of these dependencies that we outlined here. These are basically the services that make the core networking stack. So with this, we just kind of pull them in, and then we can just install it. Right, we run this Helm upgrade install, and we install this in a hub network namespace, and we just run it, and the services should start populating. We'll give it a bit of time. Right, you can see them there. They're kind of coming up. And once these finish starting up, we should also have nodes in a ready status. So we'll monitor both of these for now. Just to kind of shed a bit of light on what this is, because this might be kind of confusing slightly. What this is an opinionated setup of Kubernetes. So I've been working with it for the better part of the past decade. And from my perspective, this is how it should work, right? These are all of the components that you need in order to kind of make it whole and make it functional. And that's kind of the idea with the atHomeHub project overall, right? It's just kind of my idea, and this is how I run my own home lab, right, or home hub, I guess. And yeah, that's hopefully that gives you a better idea on things. But we can see nodes are now ready. Almost all of these are running. We need to wait for these to become healthy as well. But this installed quite a few things, right? We can see them here, like we have 14 and core DNS symmetric server there before, so 12 pods are now running just out of this this install, and that's fine. We can have many of these. There's no problem with that. Core DNS symmetric server that were there before are also running now, right? Everything is okay. And let's just kind of close these off a bit. Just so we can also see the nodes where these are running on. I'll just kind of dismiss the containers as well. So you see most of these are working on the controller, I guess. Actually, more of these are on the worker than on the controller, but that's okay. I'll put the containers back just so we can see that. As I said, this needs to be installed twice, so I'm just going to run the same command again and wait for that to complete. Give it a minute. These are okay, right? Like it gives us a warning because we don't set this spec, right? We don't have this in our certificates, but that's okay, right? We're good with it. Always updating the private key, so that's fine. We see 2 new containers also came up, right? This is a cert trust, and this basically trusts our new root certificate across all the nodes, so the nodes themselves can access back resources within our deployments if we need to. We're using this across the applications that we're installing just so they can communicate between each other securely. We'll talk more about this later. But that completes the core networking install. Now the next part would be routing. This also needs to be installed twice. So we're going to go into routing. And if we open this up here, we'll have the same dependency update that we need to run. And we're going to install it as well. So we'll wait for the new resources to come up. Okay. So this is basically the Kong pods that are actually gonna, serve traffic for our applications. So those are those, and the search server will interact with it in a minute once we actually get the DNS installed as well. So I'll give this a minute to finish. It's basically waiting for these to start up, and then we'll move on, or we'll actually install it again, right? This needs to be installed twice. So, okay. Now, the next one is DNS. So I'm going to go back and access the DNS chart. And over here, we do the same. Helm dependency update, and then the install command. And this doesn't need to be installed twice, right? This is just once, and that's okay. And let's wait for it to start up. We can see Pi-hole is here. We have a few containers with Pi-hole. Basically, the DNS server is running with Unbound as well, which is some kind of DNS server that can It can basically serve as an upstream DNS for Pi-hole, so you don't need to use the Google DNS or the I don't know, some other DNS server. I don't know. I've been using this for quite a while, so I don't know. It basically uses some root hints, and from there it can build up the resolution of all of the records. So that's just how it works, and it's been fine. Like I've been using it like that for quite a while, and it's been okay. But with this installed, right, we now need to kind of use it ourselves, right? We need to set it as a DNS server. So if we go to the network section here and under services, we'll see these service types. So as I was saying, we'll have a lot of these cluster IPs, and these are only internal. So from my local, I cannot access these. But these, as we can see, we have external IPs over here. So I have 192.168.69.10, and this is Kong. So I can probably curl it from my local. I can just do this, and I didn't copy that well, but I get a response from it. Right, this is just a basic response from it, so at least I know that I can access it. And I should be able, if I have dig installed, I don't know if I have it, but we're gonna give it a chance to test. Yeah, let me just try. Okay, so we can run dig now, so we can do this command over here, right, with the correct IP address for us. So we can do dig at 192.168.69.11, and we can do pi-hole.net. And we can see that this resolves, right, it doesn't need to be the same IP. These can change over time, so that's okay. But we can see that we do get a response for pi-hole.net. So that means that the DNS server of Pi-hole is actually working. So what we can do now is actually set it as our main DNS under our network. So you can say DNS is no longer automatic, and we want to point it to 69.11. I'm going to click on apply, and then I think let's try something. It works. Okay, so it resolves usually with like Linux. I need to turn off and on the network or something, but I guess now it worked. So that's basically the networking. We do need to trust the root CA now. Basically, if we want to go to any of these web pages, right? So let's go to this one, right? To cert at home. So if I try to, let me just make these a bit like this. So if I want to go to this cert at home, with by the way, this is like a different top level domain, right? The .@home isn't like public or something. So you do need to put like the / at the end, so it shows visit. Otherwise, it's gonna try to search for it. Just a thing to be aware of. But if we don't trust this root CA, we'll see we get this warning, potential security risk ahead. And this happens if we want to access any of these tools, right? Like, for example, this is Pi-hole, and we see it gives us this potential security risk ahead, right? That problem. So what we're going to do is accept the risk on this cert at home and just download the certificate. And now we need to trust it on our devices, and this is going to need to be done for each one of our devices individually. It is like a small annoyance, but the certificate should be valid for the next 5 years. So every 5 years you will need to do this with every device. But it hasn't been that big of a hurdle, I'd say. And I don't believe that using Let's Encrypt for your private domains is smart, right? That just doesn't work, right? It's not okay. For myself, I have this for Arch Linux, so I can just put this in. And this should trust it. And for iOS devices, right, I put it here as well. This is just trusting it on my iPhone, right? I use a lot of iOS devices, so I did this for my iPhone, I did this for my iPad, and they just can access these resources just fine. Now with this trusted, Zen should just pick it up from by default. So we can see that we're now able to access Pi-hole with the secure connection. It will give you this, right? Connection is connection verified by a certificate issuer that is now recognized by Mozilla. Because it's our own certificate, right? This is custom. This is generated for the cluster, by the way. So when you install this, your certificate is going to be different than my certificate, and so on and so on, right? Whenever you install the stacks, this just gets generated. Let's just access Pi-hole. Take a look over it, I guess. And we need a password. And for that, we can use this command. And it's going to give us the Pi-hole password, which is this one over here. This as well gets automatically generated when you install the DNS stack, I guess, and it stays the same across all deployments. And I think under settings, local DNS records, this is where we can see the DNS records being created. So this is what external DNS does. And we have cert at home, we have Pi-hole, and we have Hubble, and we'll take a look at Hubble in a minute. And the DNS settings as well, we'll see here we have a custom DNS here. All right, this is basically the unbound DNS server. I'm used to this being on the side, but I guess it's there now. And yeah, I guess that's that with Pi-hole. It doesn't have any persistence, so if, for example, if we go to pods and we delete Pi-hole, we're gonna just kind of remove it. This is gonna come back, and it's possible external DNS is also gonna crash, just because external DNS depends on Pi-hole in order for it to function, right? They're kind of tied together, but that's okay. I'm gonna restart external DNS as well to force it to sync all the records. Right, this is it does sync them every so often. So I think every 5 or 15 minutes it does like a refresh of all the records, and it just makes sure that they're up to date and set correctly in Pi-hole. But since we just restarted it, I just did a restart of it, so it might kind of force that sync with it. And you can see that now we have less queries that were executed, right? We have 44. But yeah, it doesn't have any persistence, so any change that you make in the UI will just disappear. You do have a lot of configurations for it though that you can make as part of this, primarily around like the add list and such, as well as the DNS mask settings. I think those are enough. Right, the unbound DNS works pretty fine, so you shouldn't need to switch it or whatever. But yeah, that's kind of what's configurable as part of the atHomeHub stack. So another tool that we have at our disposal is Hubble, and Hubble is pretty cool. This comes from Cilium. So since Cilium controls our entire traffic within the cluster, we can use Hubble to monitor the traffic. So for example, if we look at Hub Network, which is the namespace where all of these were installed, we can actually see all of the different network requests that are happening within the cluster. So for example, I can click on Pi-hole, and then I'm focused on Pi-hole, and I can see kind of requests coming into it from port 53 and 80, as well as the graphs are kind of weird, right? These are dynamically created, so it kind of tries its best, but it's dynamically generated, right? It's still pretty cool to see it, but we need to pay attention to the direction of the arrows. So for example, we can see that this goes from external DNS into Pi-hole, And same with Kong, it goes from Kong into Pi-hole. And this is basically the access on the web interface, right? And we can also see requests made to the world. So these are basically requests made on port 53. We also have some on 443, so we can try to maybe focus on those and see if we can figure out what requests it made to port 443. It should be here somewhere. There are filtering methods for this, but right, you can just look through this list as well. So Pi-hole made requests on 443 to 148, 82, 114.6, and a bunch of other IPs as well. We could probably do a reverse lookup on this, or we could just search for it and see IP info maybe. It's been a while. Oh, it's GitHub apparently. Okay. So no, GitHub. So I'm assuming Pi-hole connects back to GitLab to do some stuff. Not sure, but as we can see, this is pretty detailed. So in case we have some workload that we don't want accessing the like the internet, we can also block it, and we'll do like a different video where we discuss about the rules that we can set on it in order to block requests. But if we want to just kind of test this out a bit, right, to see kind of how it looks like with live traffic, we can see that the search server is nowhere to be seen here. So I can I can access it in a different page, and that should also show up here. So I can see it now, right? It just kind of came here. And if I click on search server, I can see that I just have one connection from Kong going into it. And as I refresh the page, more of them should come in. Like we saw one, and now I think it's just kind of cached from my local, and maybe fetching it from time to time. But that's just kind of a cool, I'd say, tool, right? To kind of take a look at your network traffic. Kong shouldn't be doing any outbound calls. I have to check on this because I did, I remember explicitly disabling anonymous reporting on Kong. Right, I have like the ingress controller anonymous report set to false. I don't see it querying it too often. Actually, let me just focus only on this. And I think I can. Okay. So these are basically my requests to it. And it was 10 minutes ago. Right, like about 10 minutes ago it made these requests. So maybe it just does it during startup, but that's also kind of mischievous. Like, why are you calling home, right? Why are you doing this request? But as I said, we can block this, and maybe this is what we're gonna block. But I'm getting a bit sidetracked. There's still a lot to go through. This is just like the networking stack, right? Just the network stack. So we now have DNS, we have like the overlay network, we have certificates with SSL support, we've got like the proxy server. I guess the most important part to mention is that you do have encrypted communication with all of your applications, and you do need to trust the certificate, but it's not like that big of a deal, right? You can do it once every 5 years, right? You're gonna have to refresh it. And that's okay because you'll change your devices, or maybe you'll forget to remove the certificates. It's good that after a while, some devices don't really have access, and you can kind of do that refresh. So next up we have storage. Storage is also a pretty big thing in the setup. This diagram is kind of weird. Right, we just have like This is basically the setup that we did, right, with the boot disk on each machine and the personal disk and whatever, and we have Longhorn to deal with the replication and the two storage classes that we'll be provisioning. We'll go over this. This is also pretty big, but it only involves Longhorn, so unlike the core networking stack that had Hubble and had like Hubble, Cilium, Pi-hole, and whatever. This also only installs Longhorn. So I'm just gonna switch to it here. This has some additional configuration as well, right? We have this storage config. Just because storage, as I mentioned in itself, is a pretty important thing, I'd say. I considered it best to manage these independent of each other. So we kind of have the storage config and the general config as two distinct components. And this is split into two parts, right? We have the node config and then the storage classes. If we start with the node config, right, all of these we can just kind of put them here. I'm just going to remove the comments just because I'm going to remove the comments, make this a bit cleaner. Okay. So this depends on how we define the nodes in our previous video, right? For example, if we look at the controller, we have this personal disk over here that we pointed to the SDA. So this needs to find its way here, right? And if we had like multiple devices or multiple disks, let's say we had a disk 2 as well on dev SDB, not the case with these small form factor machines, but we could have, we could have this on different hardware setups. So in that case, we just say this is disk 2. So basically, the name of the disk here needs to match the name of the disk that we define in the host install, and the name of the main block here needs to match the name of the node that we define here, right? The name of the host name from here. We then have the tags as well. Basically, this is kind of a way in which Longhorn can help you define storage classes, for example. So let me just pull in the storage class example here. And if we look at it, let me just kind of clear these up. If we look at this, we have like a disk selector and a node selector. So basically the tags at this level here are for the node selector, and the tags at this level here are for the disk selector. What I usually do is I keep one tag per disk. So for example, this is my personal disk with a personal tag. And then I add that tag as well on the node config. So for example, if I had another disk, right, as I said before, you could have more. So let's say we define disk 2, and this is maybe the testing tag. I can add it here, right? Or maybe I add another disk, and this is disk 3, and I want to use this for media. Right, I can give it the tag of media here and then add it to my overall node tags as well. So then when I want to set up like the media class, for example, so I want all the volumes created here to use the media disks on the media nodes, right? And that's kind of how I play around with these. I imagine that in more like enterprise settings, you might want to keep different disk tags and node tags and whatever, and it kind of makes sense to have these two separate from each other. But our use case is very simplistic, and we're trying to keep it very simplistic. Longhorn does allow you to set these up, but I would say keep it simple. Right, just keep the disk and the node tags some in sync with each other, right? As I showed you now. I am gonna duplicate this. So this is the node config for the atHomeHub controller, but we have two nodes. So we have, let me just make sure that this doesn't get changed, but we also have the worker here. So I'm gonna get the config from the atHomeHub worker, and this also has the personal disk. So basically the configuration stays the same, right? And this is it, right? This is my finalized storage config. I just have the configuration of each one of the nodes, where I tell you the disks, and then the storage class that kind of adds on top of those disks. Now, this is something that we can also export, right? We have this HomeHub storage environment variable. So we can do export HomeHub storage, and this can go to at HomeHub configs storage. And now if I do HomeHub storage, right, it's correct. But similar to what we did with the gconfig, I'm gonna put this in my zshrc file, just so I retain it here, and I don't need to worry about setting it up in the future, right? I just save it here, and now anytime I open up my shell, I know it's gonna exist there. But this is this setup. It was stuck there, so let me just take this to the side, and let's get back to this. Right, we have this configuration basically done, right? That's kind of it. Now we can go to core and install this as well, right? We see right, and it's pretty obvious in the install command what configuration files you need. So up until now we just had this -f homehub gconfig, but now we also have this -f homehub storage, so that's kind of a difference there. I'll download this as well, and then we can just install it. So we can okay. Yeah, I didn't restart my shell basically, so I'm just gonna close this off, and then open it up again. Basically the HomeHub storage environment variable wasn't set. Like, I saved it in the zshrc, but you do need to source the shell or just restart it, right? You close it off, you start it up again, and then it just works. Right now we have it. So now if I run this again, it should work. Fingers crossed. So we'll keep an eye out on things here. This is happening in a different namespace. So right, if you look at all namespaces we saw network before, right, that's kind of where we worked so far. But this is happening in the hub storage namespace. And this is going to take a minute to install, right? As I said, Longhorn is also a pretty complex thing. Right, managing storage is not necessarily an easy thing, right? So we're gonna give it a moment for everything to start up and be okay. And this isn't something that we need to install twice or anything like that. Right, we can just install it. All the pods are now available. We can also look into the storage section here, and if we check storage classes, we see them. Right, we're like, for our purposes, we're primarily working with the personal and the system storage. These are just default storage classes that come from Longhorn. I never really, given it any thought to remove them or anything like that. We just have personal and system, and we'll just install stuff with those two. And we'll add more as we progress and we install different stacks. Right? Like for media, we have a different storage class. For AI, we have a different storage class, and whatever. But that's that. And you can switch which storage class we use for the different applications that you install. So if you want I don't know, image to run on its own disks, right, as opposed to everything else, you can do that setup. And I'm hoping we can go into more advanced setups in the future. But for now, I just want to keep things a bit simple. But we should be able to access the Longhorn UI. So I just went to this Longhorn storage at home here. And this opened up. And as you can see, we have no volume right now because we haven't installed anything. We do have our nodes and the space available on each one. So these are split between two. So the default disk is what remains after we install like CoreOS and K3s. So out of the 256 gigs, we're left with 150. And this is the secondary disk, right? The one that we defined in the settings, which has 446 or 450 gigs available. This is the second SSD, the Micron drive. But that's it, right? We've installed Longhorn now. We have storage. So let's just move right ahead. And the next one is observability. So this is the observability stack. We have 4 components here. This is kind of optional. I was having some issues at some point and they put in like a process exporter that monitors the processes on the node. I'm just not going to deal with it as part of this install. We can roll it out, but I haven't really accessed it that much. Besides the time I was actually having some issues. You could make a case that you should install it, so you fetch that data. So if you have issues, you have the data to reference, but whatever, we'll install it as well. But we'll start off, same as with all the other stacks, with the core. And this is basically Grafana. Right, like let's just switch to all namespaces again here. I forgot to put the Helm dependency update here, but you do need to run the Helm dependency update just as before. And I'm going to install this in the Hub observability namespace. So I should just run this and we should see things coming up. So the Hub observability namespace is there. This is also going to request a persistent volume. So you can also switch back to Longhorn as this is installing. And we can see that we now have 1 volume. And we can see that this is attached to Grafana on the HomeHub controller node. This is kind of where we can see this. We can also see it's using 48 or 53 megabytes. So it is using like almost no space. We also see that it's replicated, this is something nice that Longhorn does for us. So it replicates the data across the 2 nodes. So we have a replica on each one. And that way we have like a read one setup, where even if one disk fails, we have the replica of the data on the other. So we can access it from there, I guess. That was core. Now we can move over to, I guess, metrics was next, with Prometheus and basic exporters. So let's go to metrics. I'm going to do the dependency update. And we leverage Prometheus for monitoring because it works really well with Kubernetes. It also comes with some exporters, like this chart comes with some exporters and such. And it's basically going to give us visibility into what the machines are doing, right? What the workloads are doing and things like that. This might take a minute as well to install. It's not necessarily big, but it just takes a minute, right? We can see all the things coming up. This is the Prometheus one. All of these are running usually whenever you have a kind of a disk associated with it. It takes a while for the disk to be created. Or if we go back to volumes, we'll see that there's another one that just came up, right? This additional PVC, and this is the one that's associated with Prometheus. And we're waiting for that to be running, and it's okay now. So now we can actually see that we have 2 volumes used. Right, I'm just kind of going back between like Longhorn and the rest, just because we're actually provisioning some volumes, so it's nice to kind of see it. And you can also see that the usage is only on the default disk, the one that we use for the system. We've allocated 61 gigs out of the 150 available, with actually 351 used. So this shows how much you have allocated and this how much you have used. And if you click on this button here, you'll also see the replicas that exist. We have nothing on the personal one because we haven't installed anything that takes advantage of that. But that's that, right? That's metrics installed. Let's deal with logging as well. So logging is one of those things that it's also good to have. I've also forgotten to add this to the docs over here. You kind of need to run Helm dependency update on each one of these, right? You're pulling out those primary charts, right, locally in order to install the complete chart. As we install this, right, logging is composed of 2 components. We have Loki, which is the storage solution. Right, this is, I should have linked to like the Loki page or something. Loki. Let's see if we can find something nicer to look at. Anyway, Grafana Loki is basically the storage solution that's there for our logs, and we use this prompt tail, which basically fetches the logs from the clusters, from all the workloads running in the cluster, and just publishes them to Loki. So then we can check them out in Grafana. But this also needs to start up, and this should also occupy a volume, right? We should now have 3, as we can see, and now we have 111 gigs allocated from 149. So these are the 3 volumes that we have just for the observability stuff. And we're gonna install this as well. Let's just wait for this to finish. So let's do this as well, because why not? Okay. And then we can install it as well. And that should be that. Okay. So now we can actually access Grafana and see what we've got. I mean, I should have linked this. I'm gonna try to update the documentation, but it is what it is for now. Sorry. I also don't have details about the password. The Grafana password is also generated during install. So if we go to config here and secrets, we'll see Grafana here. And we have this admin password. This is base64 encoded. So if we click on the show, that's going to be the password for Grafana. So we can do admin and this, and it's going to log us in. And I guess we can just take a look at the overview for now. Prometheus still needs to kind of scrape this and kind of write some history of these. But we can get some idea of our cluster and what it's doing. So we can see the version info here tells us details about the various versions, like the CoreOS version and the KFresh version and whatever. We have temperature details here. So we see, right, it's kind of 57 degrees for these two machines. I did notice that the controller, like in my setup there, the controller is at the bottom, and I have the worker on top of it, and the controller does heat up a bit. It's kind of a thing that happens. So pay attention to the temperatures, and if you need to, you might want to readjust those a bit. We have the CPU usage, we have the CPU load, we have the CPU usage by namespace. So you can see hub network is using this much, observability this much, and storage this much, right, like out of CPU. All the workloads that we have running, so we have 50 total, so 50 total pods, and this is how they're distributed across the two nodes that we've got. Right, like 52% of them are on worker, and 48% are on the controller. The memory usage, and it's pretty low, nothing to write home about. Nothing on the storage. This will need to reinstall Longhorn to get it working. It's kind of a thing with Kubernetes, right? Basically what happens is that now that we've installed observability, we've given the cluster the capability to observe stuff. So all the things that we installed so far, they didn't have this context, right? They weren't aware that this capability exists. So we are missing some resources that would actually, be useful for observing. But we'll go back and enable that as part of a different thing in a minute. For now, we'll just move on, and the next one to deal with is the managed services. So this managed services with the core services stack is the one that most of our applications are actually gonna require, right? Like this provides us with, as the title says, managed services. And managed services are kind of a thing nowadays, and that's what makes Kubernetes so special overall. If you think about it, everything that we've installed so far is in one way or another a managed service, because once we install it, we don't really deal with it. We just kind of let it do its thing, and as we install more things, it keeps track of everything that's being installed and the changes happening, and kind of constantly reconciling those resources to ensure that everything is okay within the cluster. But these are the more, I'd say, common sense of a managed service, because I'm just going to start the install, but what this is going to provide to us is Postgres database, right, or the capability to run Postgres databases and the capability to run Redis clusters. And as we'll be installing applications, right, in the next video we'll start kind of installing applications. These are the two most common dependencies for any of the applications that we install. Right, like image needs Redis and Postgres. Authentik needs Redis and Postgres. We're actually going to be installing Authentik in a minute. Most of the applications need either one of these. Rarely you need none, right? Those exist as well, especially on the media side. Like the media stack needs none of these, although they could. Right, like radar, sonar, those could run with Postgres database, but right, we're not doing that for now. But it's good to have this within the cluster, and this doesn't do anything as such, I guess, right now. So we can see that if we move into the Hub apps core namespace, this installed some components. Let me just maybe make this like that so we can see the full name. But we have the CloudnativePG pod, and this is the one that actually creates the Postgres clusters for us. We have the Barman Cloud Deployment or pod, and this is for CloudnativePG backups. We'll talk about backups in a different video. And the Dragonfly operator is for providing our Redis clusters. It is different than Redis. It is Redis compatible, but Dragonfly is like a Redis alternative similar to Valkyrie, only that it's better. I don't know. The operator, from my perspective, makes managing the clusters so much easier, which is an important thing. Right, whereas with Valkyrie, you don't really have that, or last time I checked, none existed. Right, and I know, I prefer this, and that's what we're gonna use. The other thing installed is the external secrets. We'll go into this in probably the next video when we'll be talking about the secrets, Bitwarden and Vaultwarden. We need, like, this provides us with the functionality to kind of tap into Vaultwarden to pull secrets from it. But we'll go into that in a different video. The most important parts, and I need to update this documentation to mention the external secrets. The most important parts, though, are the CloudnativePG and the Dragonfly operator, right? Since those are going to provide us with the services that our applications will need. Anyway, those are the managed services installed. We'll talk about the Bitwarden ESO once we get to that point, right? We need Vaultwarden installed to deal with that. But after the managed services, the next one is SSO or user management. And for this, we only have Authentik, right? Like in my previous iterations of this, I had Authentik as an application, part of the application stack. But I don't think that's okay, right? We should have Authentik as a foundational piece. Let me just get this started and we can talk more about it afterwards. So same as before, just Helm dependency update and then Helm upgrade install for this. So in my opinion, single sign-on is a fundamental thing to have. And I know not all applications implement single sign-on, and that's fine, right? If they provide even basic auth, we can make it work through Authentik to some extent. But, right, you need to use this, right? You need to manage your users kind of in a common place across all the applications. I think this is the primary reason why I was also able to convince my fiancée to use these. Right, when I started off my home lab with Kubernetes and whatever, the internet didn't suck as much as it does right now. Right, like you didn't really need like self-hosted services that much. But nowadays, I think they're becoming like a critical thing to our existence, I'd say. Right, the internet is just going to shit, so it is what it is. But without single sign-on and having to manage users on each application independent of each other, is kind of a pain, right? Like if I would need to go to my fiancée and tell her, hey, for this application you have these credentials, for this application you have these credentials, or for this application you have these other credentials, or having to having to know her password and manually set it the same across all the applications, that's just like BS, right? That doesn't work. That's not okay. She needs to manage her user herself. Right, so that means managing her own passkeys or managing her own password or tokens or whatever, right? Like it's her user to manage, it's her data. It doesn't need to be linked with me. And same for myself, right? Like I want the users to exist, or I want my user to exist across all applications. I don't want to manage my user across them differently and whatever, right? So Authentik is pretty easy to use. Right, like Keycloak and Ophelia are two alternatives to it, but I think those aren't as nice as Authentik. Right, Authentik keeps things pretty straightforward, I'd say, pretty easy. And that's why we want to use Authentik, right? It's just a bit nicer. We can see that it installed here, and if we go into the hub of Authentik where this installed, we can see we have a few things. So this is kind of where those managed services already come into the picture. We have the two database replicas, and these are basically the ones managed by CloudnativePG, right? It created these pods for us, and it manages the replication and ensures that the cluster is okay. We then have the Dragonfly pods, and these are like the Redis option that we set for the cluster, and then the server and the worker for Authentik. Now, we do need to run the initial setup. So this here links to this Authentik app at home /if/flow/initial setup. If you choose the different global DNS root domain, then at home, just make sure that you adapt this to whatever you've chosen. Right, the links from the documentation are all built with the assumption that you used at home. It's fine to use something else, but just keep in mind that you'll have to update this to something else. Now, we have a problem. Basically, we don't have a password manager, right? So I'm gonna set this up, but the password, I'm gonna have to store it somewhere until we actually get to do Vault Warden and whatever. So I'm gonna create this temp text here, and I'm gonna store my passwords here. The moment we do Vault Warden, I'm gonna regenerate the password for Authentik, just because I don't like passwords being stored anywhere locally except the password manager. But I'm just gonna set this as admin at local.athome. This is so I guess this is gonna be saved in the password manager of Zen. It is what it is, I guess. I'm also gonna put this email address here just to kind of keep it around. And that's that, right? I'm gonna click on continue. I'm not gonna update it. I'm gonna log out though and try to log in again just to make sure that everything is okay. akadmin is the admin user of Authentik, and I can log in just fine. So this is Authentik, right? It's a user manager. I'm gonna set some things up initially now that we're here. Right, if we go over this documentation, I want this Passkeys support to be enabled. And I'm gonna do this from the admin panel over here. Right, like Passkeys are basically the best way to authenticate with something at this point in time, right? They're kind of similar to certificates where it's basically, or like I don't want to say this because there's definitely going to be a way to do it, but it's close to being impossible to hack, right? So whenever I can, I try to use Passkeys to authenticate, and we do need to enable this option in Authentik. So what I'm going to do is I'm going to go to the admin panel. This is the admin panel. I'm going to go to flows and stages here and flows. And I'm going to create a new flow. And this, I'm just going to fill in the details from here. So passwordless authentication with this title here. And the designation is authentication. I'm going to click on create. then I'm going to go back into it, right? Passwordless authentication, switch to stage bindings, create and bind stage, and I'm going to go for authenticator validation stage. And I'm going to call this passwordless authentication. Device classes WebAuthn authenticators. There. And not configured, deny the user access. Okay. Click next and finish. And then I need to do another create and bind stage, this time for user login. User login stage here. And I'm going to give it name passwordless authentication user login. Next, and then order of 10. Okay, so now that we've created this, we need to go to the main flows page and click on the default authentication flow. And I'm going to go to stage bindings, edit stage on default authentication identification. So this first one, and under flow settings here for the passwordless flow, I'm just going to select this passwordless authentication that we just put together. And that's it. The user security key option will now appear in the default user authentication flow. So basically, if we click here, right, this is the login page that we were at before as well. Now we basically have this option, right? Use a security key. And if I click on this, it's gonna basically allow me to use a security key. I don't have anything selected, I guess, but we can enable this under MFA devices, so we can enroll on WebAuthn device. I'm not going to do it now because I don't want to do it with this. We're going to do it once we have VaultWarden installed, and we're going to do it through that, and we're going to use that to store the devices. So for now, we can't really use it, but we've set it in order to be used, and then once we install VaultWarden, we'll go through this as well. Now, we also have this atHomeHub integration to deal with. So basically, right, Hubble or Longhorn, these are open to the network. So if I open this Hubble, right, in a private window, it doesn't ask me for a password, doesn't ask me for anything. Longhorn, it's the same, right? It doesn't ask me for any sort of credentials. And that's not okay, right? I don't appreciate that. So we do need to enable Authentik. So we can do that by setting this in our global config. So over here, right, we have this global section that's over there. So I can just paste it here. And this is basically how this is going to get created, right? This is going to be a service internal to the cluster. So whenever we see SVC cluster local, this is basically internal, right? From my machine, I cannot ping it, I cannot access it, I can't do anything with it, but it exists, right? As part of the Authentik deployment, it does exist. And we'll get back to this actually now, I guess. Let me make this bigger again. We can go back and reinstall network and storage to have this enabled. And the nice thing about this is that now we're also going to deal with monitoring at the same time. So enable like authentication on those, as well as monitoring, right? And then the tooling will be the last. We'll leave that last. And actually, I forgot to mention integrations, so I forgot to put it in this doc. But we'll deal with integrations as well in this video, just to wrap up the entire foundation series or the entire foundation video. But let's go to storage. So I just do the Helm dep update always, right? It's kind of reflex, I guess. I didn't need to because all the dependencies were already there. But with this configured, we can now again, double check you have this and make sure it's saved. But with this out of the way, we can go and install it. I'm just going to switch to the Hub storage namespace and just do a reinstall on it. And we should see another pod come up, and that's going to be this this proxy service that manages the authentication through Authentik. There we go, right? The Longhorn auth. That's the one that's going to deal with this. Just give it a moment. And Longhorn does some stuff as part of the upgrade. I haven't had any issues running these upgrades with Longhorn. Like, I think I have 70 something installs of Longhorn on my own personal clusters, as we've been kind of tinkering with it and trying some stuff out, and it's been fine. Like, it hasn't complained that I kept on reinstalling it over and over again. But now that this is installed, if I try to refresh this, gives me a bad gateway. And that's because we haven't theoretically finished the setup in Authentik. If we go back to the admin page, and let's open the Authentik docs to the side as well. So as part of the atHomeHub integration, we needed to, set this. We also need to create some provider or some applications with providers and add them to the outposts. Why we get a 502 bad gateway there is that this doesn't even have an integration, so I can integrate this with the local Kubernetes cluster. And this is gonna at least give me a different error. So now if I refresh, this is gonna give me this not found error over here. And basically this tells us that there's no application within Authentik for this host, right? And that's what we need to do next. Right, the entire setup of it is detailed in the Authentik documentation. But what I did, I also added some details about it in this one, like what settings you need to fill in. It's a pretty straightforward process. You don't really need the documentation. It's there if you want to reference it. But we just go to applications, we click on create with provider, and here's where we just fill in some pretty basic details about this. I've also given a group. This impacts how they're arranged in the UI of Authentik, right? You don't need to actually put this in, but you can. And then we're going to select the proxy provider in the next page. Click next. We're going to select the default provider authorization implicit consent. If we select explicit, there's going to be one more page that we need to go through before accessing Longhorn. That's like no need for it. We'll then set it as forward auth for single application. And then set the external host with the host that we have. Again, if you change your root domain to something else, make sure that this matches to whatever it is that you defined. We'll then click next. This is where we can limit access to certain groups. We'll deal with this later. Right, I'm not doing a deep dive into Authentik right now, but we'll have to do it. One thing that I also do is change the logo here, right, the icon of this. I'm just going to put it here. Right, this is the icon that I've used at home, and I just kind of put it here, and then makes it look prettier, I guess. And then if we go back to the outpost, we have the application here, and we just need to put it to the right here, so it's selected for this outpost. And now, if we go back to the other window, we should refresh it. It will take a bit of time. But now we try to access Longhorn. Right, so again, Longhorn storage at home. It redirects me to the login page because I have no valid authentication. So now I need to actually authenticate. And now that I'm authenticated, I can access Longhorn as well. All right. Pretty easy, and this kind of allows us to add authentication whenever authentication isn't available, especially for these operational tools. Like Longhorn gives you access to do stuff on the volumes, right? So for example, if I want to change the replica count on this volume here, I can do it, right? And I can make this have only 2 replicas instead of 1. I don't even know what this is, Grafana. Right, and then I can delete a replica if I want to, right? And then that's problematic, right? Because I can delete the entire volume even, and we should protect this. Even if it's in our local network, right, we should still take the time and make sure that these resources are protected and nobody can actually access them on, right, other than ourselves, right? We need access to them to manage them, whatever, but nobody else should manage them, I guess. Now let's do the same for Hubble. Right, that's also something that we can do for this. So again, we go into networking core from where this was installed, and I'm just gonna run this install again. Right, no other properties, nothing like that. And I'm gonna switch to hub network, so I keep an eye out on this here. So let's see. There we go. Hubble off. And okay, that finished. So now I can go back to this other window, right, to this private window that I had. And I can do refresh here. And again, we're greeted with the same not found because, well, right, we don't have that provider. So if we go here, we'll see kind of a similar documentation to what we had on Longhorn. So I can go to applications, create with provider, and I'm going to do the same thing. Hubble, operational group, next, proxy provider, forward off single, and implicit constant, whatever. I'm going to set this external host here. Next, we'll deal with bindings at a later time. Submit. I'll edit this with the with this. So icon for this. And there we go. We have the icon for Longhorn, for Hubble. And we'll now go to this outpost, put it there, update, and that's that. So now if I go back to this page, I should be able to refresh. Right, we need to wait for Authentik to update the outpost or whatever. It takes a minute. But now we're accessing this, right? And if I open another private window, I don't know if this maintains... this keeps the session between the private windows. But if I sign out, and then I try to go to Hubble, actually you see it already kind of right, broken the connection to the backend there. But we see get redirected, and the same for Longhorn. Right, it asks us to authenticate. Nice. We do need to create our users. We do need to create stuff, right, in order to kind of better manage, right, the single sign-on stuff, right? Like we do need some groups created. We do need some users created. I'll probably talk about this in the next video when we go over Vault Warden and Bitwarden and secrets and stuff like that. Just because right now without those, it's going to be a bit tricky to set these up, but we'll do that then. Now, I mentioned I didn't add integrations here, and that's kind of my bad. But integrations, I put these as a way in which you can take advantage of hardware capabilities on your machines. These 6th gen i5s do have some hardware capabilities. So we do have an iGPU with them, right, which currently, if we go and take a look at our nodes, right, if we look at the capacity, we see that we only have a CPU, ephemeral storage, huge pages, memory, and pods. So nothing related to a GPU. This is where we can kind of fix that. We're not actually taking advantage of it so far. So we're not using the GPU in any of the applications on this stack. We do use them in the media stack, so we could take advantage of it there. But I feel it's still pretty good to have it installed because you never know when you're gonna need it. So from my perspective, it's always better to just have them there and not use them, especially since these consume very little resources. Nothing like with storage, network, observability, and the actual applications. Those are our main CPU and memory users. But stuff like this is pretty basic, doesn't really get in your way. So in my perspective, it's usually better to just have it installed. So the core just installs this node feature discovery, and this is going to add details on the nodes. So now we can see at the labels, we have a lot more labels added. So these are basically node related functionality that the tool discovers for you. So for example, it tells us the multi-threading is false, right? Like the CPU doesn't have it. It's model family 6, so I guess 6th gen. It's an Intel. It tells us the kernel version, right? Multiple forms, right? What else? Anything else that might be important? It should tell us that there's Fedora version 42. I don't think it can make the distinction between CoreOS or Workstation or whatever. It's just like Fedora. It has all of these like CPU things that I've never really found like a way to take advantage of them. But yeah, they're there. So if in the future we'll ever need them, we'll be able to use them. But the more important part is Intel, right? The Intel integration itself. And this is also something interesting with Intel. And this is easier than what NVIDIA does because NVIDIA can do this as well. But with NVIDIA, it's much more difficult to kind of break up the GPU into smaller GPUs, and especially on the ones that are available to us, right? Like GTXs and RTXs and whatever. That's pretty tough. But with Intel, we can just tell it how many devices we want per node, and it can just do it. So I'm gonna add this in my global or my general config here. So I'm just gonna put it here. I'm gonna leave it to 1, but right, just because we're not really using this. But if we'll want to use this, right, if we want more of these, we can get more of these. So let me update this as well, and then we can install it in our clusters. Let's see it come up. So we have these coming up. I had to create this symlink clean daemon set because I was having some issues with actually allocating the GPU. I still need to see if that's needed or not. We see Intel GPU plugin is coming up, and that's done. So now if we go back to our device, to our nodes here, I can go into capacity. There we go. We see this. So GPU Intel Core i9-15. We have it to 1. So we have 1 GPU available to allocate on this node. And same on the other one. We should see GPU Intel Core i9-151. So we can allocate this GPU to workloads if we ever need to do it. So pretty easy to do. So, if we're at it, why not? And I guess the last part to do is tooling. This is pretty simplistic. This just has the key-free automated upgrades. So I kind of installed K3s 78 days ago, right? That's when I did the CoreOS install. So I'm coming back at this after quite some time. So we have version 133.0 as the latest one, and I think the actual latest one is 133.3 or 133.4. And this thing can actually help us update our our nodes automatically, right? Like we don't need to do anything about it. And this comes pretty nice alongside CoreOS. So if you think about it, CoreOS does the automatic patches on the host itself. So the Fedora instance gets updated every Saturday, and right in that time it reboots and whatever. But this updates the K3s install itself, and with that we basically don't need to touch the host install again, unless we make changes to the disk layout or whatever. But going forward, the operating system part of this should be automatically updated and wouldn't require any intervention from our side. We do need to install this one twice, so I installed it now. The controller and whatnot came became online, and now we see we have these pods over here coming up, and we can pay attention to the versions down below here. So this should start with the controller, and I am gonna lose access to the cluster for a bit as this update happens. So it does, take a couple minutes. So I'm just gonna wait for it to come online. There we go. So now it's online, and if we see here, this should change pretty soon. Maybe? Does this refresh? There we go. So 133.4 is actually the latest version available. So that was nice. The job itself is gonna fail, right? It's basically how it's basically because it also restarts the process. So it kills the K3s process in order for it to start up with the new image. But that's like not the end of the world, right? And you might see some things being restarted, and that's okay. Everything should be just back online and functioning afterwards. And now I did the same with the worker, so 133.4, and yeah, the cluster is now at the latest available version. And I think that's that. Right, if we go over and look at the compute overview again, we should have some more stuff happening here. So, CPU load, as we discussed in that previous video about choosing hardware, is gonna kind of be at its limits with the 6th gen. We will see spikes, but CPU usage is kind of low, and this should be okay for the experiments and everything that we're doing. I think I can actually go a bit, let's see. So it's been almost 45 minutes that we've had the observability stack up and running and kind of getting information from our nodes. We see the average CPU load has increased from the beginning, right? Like we started at 0.4 and 3, and now it's at 1.18, 1.23. It might settle. So, right, we just kind of installed, and during startup, resources are going to require, like CPU, I guess. We also see Authentik used a lot as it was starting up, but now it kind of settled down. We can monitor like the CPU usage using this one over here. It's a 15-minute average. So we're averaging the past 15 minutes for each data point, and then kind of show it a bit nicer like this, I guess. You'll see that network storage and observability are the primary users of the CPU, just because they constantly do things. right? Like the network components are constantly ensuring that your network is up and running correctly, right? Storage does the same thing with storage, ensures replication is happening across the different disks that we might have and whatever. Observability constantly observes your components and pulls information from them. And the rest of them aren't usually that used. So we'll see that after we install applications, unless we like upload pictures to image, for example, there's not going to be a lot of CPU usage on image and stuff like that. RAM memory usage is also 25.9% and 16.3%, right, depending on what workloads were run where. This is the controller. We have 8.56 gig used, and this is the worker. We have 5.2. This might differ based on your setup as well. Basically, we've configured the controller, like we configured a lot of the workloads that we just installed to prefer running on the controller. So that's why we might see like more pods there, although they're not, right? They're kind of evenly distributed. But it's possible the ones on the controller do use more resources than the rest. We now get the disk information as well, so we just have one volume that we created for Authentik. So if you want to do custom branding on Authentik, right, all those files are going to be here in this volume. I just deployed this because I just deployed this. I've never actually done any custom branding. I don't even know how to do it. This also tells us our actual disk usage. So we can see default disk is that OS disk, and personal is our personal disk, so how much of it is actually used. This gives us kind of how many writes are happening per namespace. So, not a lot, but right, that's there. That's good information to have. Again, with disk related information, like the write rate, I guess. This shows all of the mounts. So the OS disk has multiple mounts on it, right? This is what we mean by the system disk, right? What remains from the rest of the partitions, and this kind of gives you an idea of how those are used. Disk writes over the current time range, so right over the last 15 minutes, this is going to be lower, right? It's been less written to it. You'll see writes on this on the NVMe drive, right, on the OS disk. Like you'll see more than on the other one, just because you have like Grafana, Longhorn, Grafana, Prometheus, Loki writing to it. So that's that. We have the smart stats. These are not that useful for us. I guess they do turn out some command timeouts, I guess, for this. I don't know why I have this here, but we can see kind of the devices here. So 69.5, this is the controller. The dev SDA is the Micron SSD. Model name is here, serial number is here, type SATA, and the NVMe drive right over here. The two SATA SSDs do return some details. I'm not too concerned about the command timeout, honestly, that's fine. And you also see for how much they've been running, around 3.6 years, as well as the temperatures that they're running at. The temperatures are available in your overview as well. So up top here you have like dev SDA. And this is your current usage. This is your max over time. And you can also see them here somewhere. So dev SDA, it's that green line. And right, these are basically other like sensors within the system. We can also see this has settled down now. So it's actually kind of idling pretty nicely. We'll see it kind of fluctuate over time as different processes pick up and then do different things. Network as well, right? You should be expecting network traffic between the nodes, right? This is how Longhorn keeps the replicas in sync. This shows the physical ports, so we only have one, so this is receive and transmit on that one. This shows all the ports just because for like each container, Cilium creates like a network interface for it. So you'll have a lot of these like LXC ports around. I showed them because why not, but I don't really get that much useful information from them. And you can also see the system logs here. This just shows stuff from journal, but it kind of gives you an idea if you have like warnings or things like that. And then you can kind of scroll through this and get to the warning somewhere. I don't really use this too much. I do have it here, but if I want to check the logs, I just go to explore, log key, and I can select something from here. And then filter by that. So for example, if I want to see what the hub storage is doing, I can just do that. Right, and I see the logs from each component here. So this is Longhorn Manager throwing a warning about some deprecation, I guess, and whatever. And I think that's it. So we can just take a look at Hubble as well if we want to, just kind of see how things are kind of going now. So we see Kong hasn't made any outbound calls anymore, so that's possible it just does it during startup. But now it doesn't really make external requests. I still want to look into that at some point. We do have more things accessed, and we can see, right, this is going from Kong, but this is going outside of this white box here. So this is Hub Network, but these are in observability, in app Authentik and storage, right? Like this is basically us accessing the UIs, because all of our requests do go through Longhorn. Right, that's how we access that. But we can take a look, right, like at Authentik, for example, if we want to see this. This has all of these, like the Dragonfly pods, and you can see that these are actually kind of, I guess, Prometheus queries the master, and then this other one as well. If we look at Authentik, and we can see Evil Hubble auth proxy connects to Authentik, and I think the same would happen with Longhorn as well. So if I open a new page, a new like browser, I guess. I missed the tiling from Cosmic. Longhorn storage at home. I should see this there as well. There we go. Right, like the Longhorn auth proxy made a call to Authentik. It was an internal call within the cluster in order to basically validate that my current token is still valid, right? And I'm an authenticated user. And then Dragonfly, this is, the connection with Redis, which is using it in the communication with the worker and whatever, and the database, right? The database. And yeah, I also check Pi-hole to see what it's doing, and just kind of check it here again. I need to pull the secrets for Pi-hole. Pi-hole admin user, and just take it from Lens like that. Right, we can see we had like a total of 1,261 queries so far. Almost all of them went to GitLab, but we also had like Authentik, Hubble. We had some pings to Arch Linux, I guess. This is like user telemetry, maybe. I don't know what that does, but I can check on it. Longhorn as well, GitHub as well. Okay, we saw Pi-hole actually connecting to GitHub during startup. Oh, I guess it may be pulled to see if it has any newer versions or anything like that coming up, maybe. But yeah, this is basically most of our, like the top of our network traffic. We've been using it so far. So throughout this video, this was my DNS server, right? It was using Unbound as well. So it wasn't using any of these like DNS servers. It's our own DNS server through and through. So that's pretty nice to see. And yeah, we can also take a quick look over Longhorn. We can see now we do have more volumes than at the beginning. We do have stuff now on the personal disk. So on the personal disk, we have like 3 of them. We have that Authentik branding, and we have 2 PVCs. These are from the Postgres databases. So by default, I provision the Postgres databases on the personal disk. I think it's good to have them in the same place because these are like actual dependencies of your application. You should store them in the same place, so you have them in the same place, I guess. We'll talk about backups and how to deal with that as well at some point. And for CloudnativePG, we can also go and we should have. We don't have the CloudnativePG dashboard. Oh, because we didn't redeploy it. Okay. So we didn't redeploy it to have actual monitoring. Right, this is also something that we need to redeploy. So let me just do that. This shouldn't reinstall anything. It should just enable monitoring because now the stuff that's needed for monitoring should be there. A dashboard should come up now. CloudnativePG. But I guess this was there, just the dashboard was missing. Oh, that's pretty cool. But we can see, right, we just have this database here, the app Authentik, but as we deploy more applications, we'll have more databases to deal with. Replication shows us degraded. I think that's slightly misleading. We can take a look at the write-ahead logs, and we can see that the archiver is okay, and this is kind of a signal for the replication as well. We did have a bit of a lag, but nothing to write home about. It's like sub-second, now it's healthy. I don't know. I think this is kind of related with the backups and whatever, but this has never been an issue. I did have problems where the lag would increase just because the applications weren't used. And it was kind of related to this write-ahead log here, where the last archive age would just kind of increase to like hours or days. And then I would just log into the application and it would automatically go back. So I'm guessing if it has no rights to do, then the archive doesn't happen, right? Because there's no new information. We can see this is the one that's a primary, right? The Authentik DB1. Right, this also has the most connections active. But yeah, this is pretty cool dashboard to also check. We also have something from Dragonfly. Right, this shows us details about the Dragonfly cluster as well. So Dragonfly or Redis is a database in of itself, I guess. It's storing keys, and this can tell you how many keys you actually have per DB. Usually you just have DB0. There are cases where you might have more. I think Nextcloud and even Image might define DB0, DB1, and whatever. We see we had like 16 keys at some point, and then like some of them expired, some of them came back. You can also see them here, how many are expiring and not expiring. So these can at some point just be expired from the database. But yeah, I don't know. This is more like nerdy information, I guess. We looked over smart. Most of my time is spent in this compute overview, honestly. Like that's where I primarily end up looking at stuff. Yeah. So this has been a lot. Like I'm just looking at the time recorder right now, and it's 2 hours and 20 minutes. I don't know how short I can make this. We have done a lot though. So we basically, right, if we think about it, we've provisioned like a cluster, right? Right, as I mentioned before, when we started this off, we just had like the shell of Kubernetes. But now we actually gave it its form, right? Its foundation, right? The components that can be used by all of the other applications that we'll be installing. Right, we installed the network stack with all of the various components for us to interact with the applications, as well as have encryption, our own personal encryption, right, with our own certificate that we manage ourselves. We've also trusted that certificate on this PC workstation, I guess. We've also provisioned our own DNS server, right? We've got Pi-hole running in this cluster and it's ready to serve the entire network. So I can define this at my Unify controller right in my router. I can just say, use this IP as DNS for this network and it's going to work. And then all of my clients are going to be able to access the applications by name. We dealt with the storage. We have a way to provision storage in a replicated manner. Right, we dealt with observability. We have ways to observe our nodes and our workloads and things like that. We have ways to provision Postgres clusters and Dragonfly clusters for Redis. We have SSO provisioned. We have automatic updates for K3s, and alongside with the CoreOS updates, every part of the operating system is updated automatically. And we've also installed the Intel iGPU integration. So that's kind of a lot of work, I'd say, like a lot of things done. So for 2 and a bit hours, and then keep in mind that I also kind of talked about each one of the stacks and tried to explain it. I think if you do a speed run of this, maybe an hour and a half, and then you can just install everything. Right, the configuration itself, right, if we bring that back into view here, it's pretty basic. Like all we had to define for everything to work were these. Right, and keep in mind the Authentik stuff, we added it just to have authentication on the applications that don't offer us authentication, like Hubble and Longhorn. So yeah, I guess that's it. We're gonna close this here. I hope you made it so far and this was useful. If you want to try it, check out the GitLab page, right, where you can see all of the different components. And I'll see you next time when we'll probably deal with secrets. I think that's the next thing to deal with. Thank you for watching.